Okay, well, good afternoon, everybody. Thank you for showing up and attending another one of our weekly TESS seminars. A few little quick announcements. Of course, huge thanks to Yoko and her team for keeping everything in TESS running, which we appreciate very much. And we're very happy to confirm that we've got critical mass, at least 40 people who are going to be going to our annual retreat. And you know, those have all been really quite successful and a lot of fun. So please do sign up if you haven't signed up already. This will be a good event. And yeah, anyway. And by the way, you might have heard, we've been running TESS for 14 years now. We're very much trying to find a new director for TESS. I'm going to step down, but we're certainly looking and very much hope to keep TESS going. It's just a bit of a challenge finding someone who wants to take all that on. And this is our talk for next week. I'll just mention quickly the quest for the aesthetic value of courtship displays. That sounds fairly interesting, that sort of Saturday Night Fever kind of a thing. And then lastly, we want to introduce Professor James Watson from the University of Queensland. James has been one of the most high impact conservation scientists in the world over the last 15 years or so. He coordinated for quite a while a very active group at the Wildlife Conservation Society, while also holding a key role at the University of Queensland that was producing important papers just left, right, and center in all the top journals. Constant stream, I mean, really a remarkable stream. I don't know really any group that was probably being more productive than his group. So James has a very good academic background. Among his many accomplishments are, he was a Rhodes Scholar, which is extremely high honor. And he completed a year of his training at the University of Oxford as part of that. He was also at Sandhurst in the US in the military, right? Sort of the equivalent of West Point. At Duntrum. Oh, sorry, Duntrum. But anyway, so he has a military background, so no cheeky questions he might have to deal with you later on. But anyway, James, thanks very much. Appreciate you coming.
Thanks, Bill. A real honour to be speaking here. I spoke here about 5 years ago, so it's really great to be back and to do another seminar. And Yoko, thanks so much for looking after me and hosting me and sorting out my accommodation and stuff. It's been great. So I want to start this presentation with a photograph. This is a photo that my mother took about 35 years ago. And I'll give my age away. I was 12 years old on the banks of the Murrumbidgee River out near Hay. Now, I'm sitting next to my twin brother. I'll give anyone a beer who can tell the difference between myself and Alexander. A few of you might know Alexander Watson. He works for Wildlife Conservation. No, AWC, Australian Wildlife Conservancy, is the regional ecologist up here in Cairns. So if anyone can tell the difference there, I'll give you a beer to still tell if it's left or right, which is me. And three of my friends. We'll just hang out at the river. I think it was my 12th birthday. Now, I'm showing you this picture because it was, and in my mind, a very simple time. I looked at it, my mother gave it to me a few weeks ago, and I was looking at it going, I can't remember being that stressed when I was 12 years old. Maybe it's because I was a kid. But really, if you think about global dynamics, it was a simpler time. Since that photo was taken, the world population went from 4 billion to 8 billion people in just 35 years. We've seen a quadrupling in the amount of area under agriculture in that time to feed that extra 4 billion people. And you know that fisheries has been extraordinarily affected during that time. Again, there's been a quadrupling in the amount of fish caught since that photo was taken and now. And that's due to two things. The first is a doubling of the population. Obviously, more people eat more fish, but each individual human was doubling their intake of fish at the same time as well. So the world's fisheries have really been smashed during that period of time. The amount of mining since that photo was taken has actually gone up by 10 times. And most of that is, as we know, fossil fuel mining. So a huge amount of open cut mines around the world have led to decimation. And forests, we've actually been smashed in that period of time. I think we've lost about a third of all forests globally since that photo was taken, and another third have been degraded. So we know the reason why. We know actually why this is happening. It's the Great Acceleration. You know, Will Steffen and his colleagues from CSIRO and other places around the world have been writing about this for a long time. We know that as the population has gone, we've seen massive amount of GDP increase, resource use, energy use, land use, and this humanity's acceleration around all these things, these socioeconomic trends, have really had consequences for the Earth systems. We've changed our climate dramatically. We've changed our land uses and sea uses dramatically as a consequence. Now, the thing about the Great Acceleration, and people don't talk about this enough, is that since that photo was taken, we're really only halfway through, based on their analysis. Since I was 12 years old, all those things I mentioned is only halfway to what we're going to get to. So, you know, it's something to keep in mind. We're not at the end of the acceleration, we are still accelerating. Another thing, though, to consider since that photo was taken when I was 12 years old is how our ability to actually utilise and see the world and do science on the world. When I was, this is probably a little bit actually too ambitious, but I found this photo on the internet. This is the style of computer that I was using when I was about 15, 16 in high school. You know, a floppy disk, you know, something that would take hours to do computationally that will take seconds today. We have seen an unbelievable increase in data since the last 30 or 40 years. Since that photo was taken, 10 times, we've seen a 10 times increase in human-generated data that we can actually access to do science and to do policy around. We've seen a 50 times increase in the machine-generated data. So this has been a big data revolution alongside this great acceleration. And it's something that has helped scientists and policymakers and those interested in the Earth and humanity's influence on the Earth understand what is happening. Big data is helping us understand what the great acceleration means for biodiversity and will increasingly be important. Now, I've been obsessed with one component of the big data revolution and one particular piece of work called the human footprint. Who's heard of the human footprint here? A few people? Right, this is a piece of science started by Eric Sanderson in the early 2000s, and it's one of the most elegant pieces of work you can actually get to. He basically said, I want to know humanity's industrial level footprint across the planet. So what I'm going to do is scale human population density, night lights, urban areas, land cover change, railways, roads, navigable rivers. And I just want to ask how much of Earth has an industrial level footprint. Published it in 2000, I think two or four in Bioscience. And this was the map he produced, showcasing that actually by that stage, we were already influencing the world at quite a dramatic scale. Now, this map, it just worked in 2004, and I encourage you to read it. This is actually at a 10-kilometre resolution, and it's been cited over about 3,000 times. But what's more important is that it's been used in multiple assessments, not just biogeography or geography of humanity, but it's in assessments around species risk assessments. It's been used for ecosystem decline assessments, wilderness assessments. It's been used to map and predict disease outbreaks, map and predict carbon loss. As a tool, an elegant, simplistic tool, it has been profoundly important in many, many elements of biogeography. Now, I have been utilising that map since I did my PhD in 2004. I've been citing it regularly, but I've been more and more worried that the data used in that map, published in 2004, was, if you look under the hood and looked at it, it was data actually gathered and collated in the 1990s. So even if we're using this science and this data in the 2010s, 2015s, we're using data set from 20 years before to start talking about what humanity's influence. The data was primarily captured. I've got a photo of Bill Clinton here. He was the president of the United States when we utilised the data for that original human footprint, or well, not we, but Eric Sanderson and co. So in 2015 and 16, a few of us got together and said, we've got to actually update this. We can't just keep on relying on the old human footprint and hope for the best. And there was people here at JCU and TESS that actually drove that. A guy named Oscar Venter. People remember Oscar Venter, Michelle Venter, his wife. Bill was clearly a part of it. Hugh Possingham down at UQ. People from Season in New York, and Eric Sanderson came back on board to help us with it. And we wanted to actually think about what does the human footprint look like now, not from the 1990s. And so it was a big collaboration to do it, led by Oscar. And we were able to produce a much better map, one that it was at 1 kilometre resolution, not a 10-kilometre resolution. And Oscar published it in Nature Communications. Bill will remember the fact that we got bounced around like you could never believe trying to get it published. But we got it in, and it's been, again, heavily cited and heavily used. and it's been an important thing for us to predict species extinction, predict carbon loss, predict where species movement is being affected. So it's been driving another big set of data. Now, the reason why I'm saying, one of the actual outcomes, actually, I just wanted to stress one of the outcomes of this piece of science, which I thought was interesting because it's something that really has affected me, and I think it's something that we don't talk about enough, is what Oscar was able to show. And I need to, so on the x-axis here is agricultural suitability. And what Oscar was able to show is that humanity's ability to actually find any area of Earth that was suitable for agriculture, humans found it and then cleared it for agriculture. That's what the human footprint science showed in the Venture et al. Paper. Humans are excellent at working out what you can farm, if it's farmable, and then farming it. So when you think about climate change in the future, you think about places that are going to increase precipitation, places that you thought could not be farmable, but will be likely to be farmable in the future, we're going to farm it. Because humans are good at one thing, and that's that. That's what this piece of science shows. Just want to make the point about the big data revolution, though. So we were very pleased as Punch publishing in 2016, took about a year and a half of Oscar's life to get it done, 1 kilometre resolution. Just a couple of years later, other groups from National Geographic and other universities have published a human footprint with 100-metre resolution. So showcasing the utility of the approach is great, but the resolution is getting finer and finer. And again, when you're going to 100-metre resolution, you're seeing patterns that are showing dramatic change across Earth's ecosystems, especially on land. So my fascination with the human footprint comes from an obsession of understanding what is happening to Earth's remaining intact ecosystems, those places that have had few or no industrial activities within them. That's been my obsession. If you can look at my career of research, and as some of the research Bill said that we publish a lot on, is what's happening to these places. Until very recently, and despite many people's efforts, including people like Bill's, these places were just ignored in global policy context. If you went back and looked at the CBD from 2010 and looked at anything about ecosystem intactness of quality and its importance, just ignored. If you looked at the UNFCCC conventions, just ignored. It's only been in the last few years that they're actually talking about high integrity places, highly intact places, as places that are critically important to secure while they stay intact. This is despite dozens and dozens of pieces of research showing that these intact places are these strongholds, the remaining strongholds of biodiversity. They are incredibly important reserves of carbon. They are incredibly important water reserves. They regulate local and regional climate regimes. Not only, I'm sure a lot of you know about the science of the Amazon, that the deforestation and the effects there are literally affecting global weather patterns, right? But it's in Australia we've shown it. Clive McAlpine at the University of Queensland has shown that land clearing in the 1970s and 1980s have caused local and regional droughts in eastern Australia, directly caused it because of that deforestation, that land clearing. So the loss of these places is not just a biodiversity story, it's a weather story, it's a drought story. And it's also these places hold many of the most marginalised human communities who rely on the direct ecosystem services. These are Indigenous peoples who have managed these places and actually, and live with them for often a millennium, have actually needed, need these ecosystem services, need these systems to survive so they can actually survive themselves. The other thing that I always want to stress to any audience, and this is something we don't talk about, is often full restoration is simply impossible when you reduce and erode an intact ecosystem. It is simply, you can't get back. As soon as the first road goes in, as soon as the first dam goes in, as soon as the first mine goes in, full restoration is impossible. It's never going to happen. Something may come back, it just won't be what you lost in the first place. So when we consider the loss of these intact ecosystems, we have to consider it like a species extinction. It's something as profound as a species extinction. The loss of the passenger pigeon, we talk about a lot. The loss of the thylacine, the dodo, terrible things that should never have happened. That same language, which I guarantee has never really been used. You've probably never heard that. We've got to use that when we go into the Daintree and actually put roads through it. Or when we go into Central Africa, these last remaining intact places, and put a mine in the middle of it. You've lost it, it won't be coming back. Now, work that my PhD student, Brooke Williams, did recently showed that if you break up the world in terms of biomes, you can start seeing how little intact ecosystems is left. Even deserts, which are considered, hard to actually enter and hard to change, only about a quarter of deserts actually can be considered intact. Tropical forests and grasslands decimated. The only places that still have big chunks of intact places are the boreal areas and the tundra areas of northern Europe, Russia, and Canada. That's it. That's the story in terms of how much we're less, how little of these intact places so important for things like biodiversity and climate change. And if you look at the marine world, it's even worse. Incredibly, we've actually impacted more of the ocean relative than on land. So again, humanity's industrial footprint is everywhere, and where places are intact are often really in the deep, far places of the world. Now, why do I talk about this? Why have I got passion about intact places? There's lots of intact places. Well, it's driving, literally driving. These changes in these landscapes and little seascapes are driving Earth's biodiversity crisis. These are numbers from the IUCN Red List for species, and you can see the numbers of species that are now at risk of extinction. 30% of mammals are at risk of extinction. Almost 60% of cycads are literally going to blink out if we do nothing. Now, you've got to remember what these numbers mean when you think of something like a critically endangered species or an endangered species. If you're listed as critically endangered, the scientific modelling is saying is that nothing happens, you will almost certainly go extinct in 10 to 20 years. If you're listed as endangered, it's between 20 and 30 years. It's just a time frame. You're going to go extinct unless something happens. It's just, if you're vulnerable, at 30 to 40 years, it's just a time thing. So these numbers are our extinctions debt that is going to happen unless we do something about it. The Living Planet Index, which is something that I suggest that people read it and look at, because it's actually a stunning piece of work. Something like 40,000 different population trend data pushed together and emerged actually to show patterns of actually change across world in terms of how much life is on the planet. Shows this kind of loss. We've lost 69% of biodiversity according to the Living Planet Index, according to direct monitoring of species and ecosystems around the planet. And you can see how it's changed across the different spaces across the regions. Now let's go to Australia. I think that we can't not talk about Australia in this context. We are actually fantastically good at making species go extinct. And we're talking about trophies for the Matildas and statues and stuff like that. Well, we need a statue for what we've done to the mammals in the last 50 years. We are the gold medalist. We've actually hammered them more than any other country in the world. We're ranked #1 in the world for mammal extinctions in the last 250 years, but we've lost heaps of different species, as you can tell. And you can see one thing that we often don't talk about is where this species extinctions occurred. It's across the continent. It's not just in one little area or one island. We've lost species everywhere. And the other thing that we've got to think about is it's not happened 200 years ago and that we've got better. There are extinctions happening every decade, every single decade. The crisis is continuing. It's not like it happened 100 years ago and that, I'm sorry, that was a long time ago. We're going to try and fix it. We've fixed it up now. It's continually, as you see, and growing is what you're seeing. Since that photo was taken on the banks of the Murrumbidgee River, we've lost some of these species. The melamines, we've lost the gastric breeding frog, which is, think about what that could have done for science, the gastric breeding frog's loss. These are just some of the species that have gone extinct since the time that photo was taken on the Murrumbidgee. So, as I said before, the great acceleration is still accelerating. And we know that there's 4 billion extra people. Well, that's a lot more agriculture is about to happen. There's also even scarier stuff, not just about agriculture, but renewable energy. Now, we're going to have to transition to a renewable energy future. We have to get to net zero very, very quickly. The only way to do that is via renewable energy. I understand you've had a talk a few weeks ago on this very topic about what that means for land use and sea use, but it's dramatic. This is just one map that I've been shown from the Net Zero Australia people that shows this is where they think the best case scenario is for lots of renewable energy in terms of wind farms and that kind of infrastructure needs to go. And they've, and that's, if you're going to zoom in on that, it's an enormous amount of Australia, which has to be directly changed to get that future going. And it doesn't account into any roads, which sets that up, or any mining that has to happen to get that going. So a lot more land use is changing. And no, it would be remiss not to talk about Bill's work around the infrastructure tsunami that is about to hit us, which has not hit us like it happened in the last 40 years. It's going to get much, much worse based on the policies of China and other groups. So we're going to get something like 25 million kilometres globally increase since 2010, which is just a staggering statistic. And I know that this paper is highly cited because people talk about it. In fact, I go to conferences and people refer to this work by they're saying that's the work which keeps them up at night because this infrastructure is going to be game changing. Lo and behold, a lot of the analyses show that yes, we've lost a lot of species so far, but projected terrestrial extinctions are going to be enormous in the next 50 to 100 years based on this. So we know that a lot of these models are actually showcasing dramatic change. A lot of these models which show up a 10,000 chance increase in species extinction rates don't account for this infrastructure boom, don't account for the renewable energy boom. They account for climate and agriculture. So they're not even taking into account the threats that are going to be most changing. So these things are massive underestimates. So this is what I hear you thinking. Like, crikey, 20 minutes of ranting at us about what is wrong with the world. I think I wanted to set this up because I think we've got to get the problem into perspective, right? And we are facing a problem. We are facing some problems. And a fair question that I've been asked, and I think it's a fair question that any conservationist should ask themselves is the future of conservation and humanity bleak? Is conservation a futile struggle against the forces of growing human consumption? Are we just working to slow the rate of decline? Does it mean despite how hard we fight, will all we witness increased declines in species, continued degradation of ecosystem services, and unsustainable exploitation of nature? Will we just simply lose a safe operating space for humanity? I think that is a fair question that we should ask ourselves every day. And if you're not asking yourself that question, I think you need to raise your eyes a little bit and look into the future, because I think it's a fair question to ask. I think the answer is no. It can be no. And this is what I want to talk about in the last part of my talk. But there are two things that we've got to do better as a conservation community as we think about the future, think about what is about to happen coming down the pipe, right? We've got to recognise that there are large societal changes that are underway that will fundamentally change the foundations of what conservation means. The biggest one is human population growth. I've mentioned it's going to I've mentioned the population problem that's already happened. Well, birth rates are going down. Average population change is dramatically changing. It's been changing for a long time. We've already reached peak baby. Now, it's debated amongst demographers whether it's 2013 or 21, where we hit most babies born ever on Earth. We've hit it. It can never get to that number again. We are going down. The amount of births and the amount of deaths will equate with each other in about 30 to 40 years' time, which means the population will increase up to a certain number and then have to decline. So it has to. Mathematically, its certainty is climate change. Our population will increase to a number and then must reduce. So what that means from a conservation point of view, and sorry, actually, I will give you one statistic. The United Nations have released what they think is going to be the peak humanity, and that's 2086, where we get to about 8.4 billion people, I think it is. So yes, what I've said is the global human population will reach 8 billion, has reached 8 billion since, in mid-November 2022, and it added 1 billion people in just 10 years. And yes, the world's population is expected to increase by 2 billion people in the next 30 years, but it must peak at about 10 billion, not 8 billion, sorry, 10 billion people in the mid-2080s. So we're actually going to hit a population peak. The second big thing that we don't talk about enough, and that is incredibly important, is that most humans are moving to cities, right? Now, this transition, this demographic transition, is fundamentally game-changing for humans and for conservation. So why is urbanisation so important? I've written this slide out because I didn't want to forget any points, but there are 4 real points to remember about urbanisation. It's not about clumps of people moving into more efficient places, but urban residents continue to have less children. This is due to the fact that women in cities generally have more autonomy, education opportunity, leading to fewer children. Better healthcare in cities means that there's lower infant mortality rates, resulting in couples deciding to have fewer children. The increasing agglomeration of humanity in the cities won't necessarily mean higher environmental impacts either, because city dwellers tend to spend significantly more on the wealth of their housing, transport, and investing. So they don't want to waste their resources on inefficient things like food that is going to be expensive. And as we know, if you live in a centralised system, you get more efficient when it comes to energy use, water use, producing less waste. These are all simple facts from study after study looking at urbanisation around the world. So when you see this transition happening of people moving to cities, you start thinking there's actually a bit of hope here, because not only will the population start to decline, we're starting to see a city trend where people move from rural landscapes across the world to urban landscapes, which will encourage that trend of population decline, and at the same time mean you get less impact on the environment because people are living in cities. This is an older graph, but you can start to see the trends predicted in terms of where urban growth will occur and rural growth will occur. So you're starting to see this kind of impact of what this could mean for conservation in the future. So Eric Sanderson wrote in a paper in 2019 that's well worth reading. How will the world look like in 100 years? What is it going to look like? Well, there could be, once we get that peak 10 billion people, there's going to be a decline. So we could get, in 100 years' time, not in my children's future, not in my children's future, but probably in their children's future, they'll have a world of about 6 to 8 billion people and declining. There'll be few in extreme poverty, and most people living in centralised cities. 70 to 90% of people living in cities. So what does that mean? Why am I talking about this 100 years from now? Well, I think if we start lifting our eyes a little bit, we've got to start to see we're in a bottleneck situation based on the demographic trends that I've mentioned, and therefore we've got a role to actually get nature through a bottleneck. So right now, we've got heaps of urbanisation occurring, but a massive population growth, but you're also seeing declines in poverty everywhere, right? Over the next 100 years, we're going to go through this bottleneck where there's massive pressure is going to be on the environment. And when you get to the other side, you should be getting better wealth, better governance, better technology, maybe a conservation ethic, better women's decline, but a massive decline in birth rates, and therefore a massive decline in population, and therefore a massive decline in impacts on resources. So we've got to plan for this bottleneck. Now, right now, we're not planning. We're doing option 1, which is just letting unsustainable growth drive our agenda through this. I think this week, Australia we're talking about their 2060 plan. And they're talking about population growth being 40 billion in Australia, and what are the infrastructure needs. There's no talk about the conservation needs in what we need to do over the next 30 to 40 years in terms of making sure we get through this bottleneck. So right now, nature will fail to get through the bottleneck because all the choices we make are around economic prosperity, and which will be prioritised over conservation. The size of the bottleneck is just far too small. Too much land and sea must be changed to feed this hugely growing population, and we won't ever be able to restore it once it gets out the other side. Or option 2 might be, let's make the most of nature, make it through the bottleneck. So we can actually start talking about this long-term plan to say, look, we want to get out the bottleneck and get nature getting through it as much as possible. So proactively map and then make the case for nature conservation when talking about it, not in the next 5 years, 10 years, but the next 100 years. To say, look, this is what we need, the chessboard that is nature and humanity to look like, which has the best interests of nature. So we need to plan to widen the bottleneck. So the second part of that question is, do I think the answer is no, but the conservation movement needs to do 2 things better? Well, the second part of it is we need to be smarter and more proactive in terms of how we think about planning. And that has to be far more long-term. Now, my final bit of the talk is how you do it. How do you actually get ahead of the game? I've always thought that we overcomplicate conservation planning a little bit, and that we should just use a healthcare analogy and do what they do in healthcare. In good healthcare systems, there are three components to what they do to try and get society as healthy as possible. They focus on the emergency room, and they want to make sure that people who go to the emergency room don't go to the morgue. So a lot of money spent on hospitals, a lot of money spent on trying to stop that transition from hospital room to morgue. A lot more money, though, is spent on rehabilitation. So when they go to hospital, when they start to injure themselves, they don't want to go to hospital. So they spend a lot of money rehabilitating people and trying to get them healthy. If they're sick, get them fixed before they get actually to hospital. Now, that's what COVID was all about. That's what the vaccines were all about, like to try and stop that, people going to the morgue and going to the hospital. And the third one is preventative health, just making sure that people are healthy, happy, surviving, thriving. And that's where most money in healthcare is spent, or should be spent, in a good healthcare system. Because if you get that right, the other two things become less important. Now, I argue that we can do the same in conservation planning. We've got to prevent species from going extinct. We've got to, when species are sick, they're endangered, they're about to go to the morgue, we've got to actually prevent that. We've got to set goals to do that, stop species extinction occurring, and spend some resources on that. But we've got to also stop species from becoming less common. Common species should stay common, ecosystems should stay less degraded. So we've got to actually to stop and halt ecosystem decline. And finally, we've got to retain ecological integrity, keep intact places intact, because that, from a biodiversity point of view, is how you keep, from a healthcare point of view, the whole system functioning. So if you look at the conservation response in terms of a healthcare response, you can get to these three automatic goals. And they can easily be translated right now into area-based conservation targets that will get us in that 100-year timeframe that gives nature the best chance of getting through the bottleneck. So you can actually calculate this. We have calculated it using broad data. We published in Science a couple of years ago, basically saying, if you stop extinctions, if you stop decline and you keep intact places, what you need to do is conserve about 44% of the planet right now on terrestrial Earth. If you do that, based on best available data, you'll get those outcomes. In the ocean, we've shown that it's about 28% of the ocean needs to be protected based on those three goals, those three healthcare goals translated to conservation. Now, I acknowledge that it's based on best available data. So all the ISM data we can use, we've used, but there's a lot of biases in that data and there's a lot of gaps in that data, but we can only use what we've got. It's also blind to climate change. We didn't incorporate any climate models, and we probably should to get those numbers more accurate and make a climate resilient system. But the point of those global analyses that I've showed you just then showcase you can do this. It is possible to plan for these places and put them into local scales. The other thing I didn't do with those 44% and 28% is consider other ecosystem services that need nature. Things like carbon and stuff like that need to be considered in these systems. So when you think about what others have written on this, these numbers that I'm talking about mirror. E.O. Wilson, the late E.O. Wilson, talked about half Earth, and he was arguing that at least 50% of the country of the world is needed to secure species based on his species-area relationship. The Europeans have argued that about 50% of species, 50% of the planet is needed to actually avoid mammal and bird extinctions. And Jeremy Simmons from the University of Queensland did consider carbon, did consider water, as well as biodiversity thresholds, and showed that while 80% of terrestrial vegetation is needed, that's about 60% of the planet that is needed to conserve biodiversity. So my point is the numbers are actually starting to come in about what do we need to get through the bottleneck? What do we need to tell policymakers to get through the bottleneck? And it's about 50 to 60%. Now when I say that to people go, you're joking. That's never going to happen. People are never going to safeguard 50 to 60%. No nation will ever agree to it. Well, here's the truth. In the Kunming-Montreal Global Biodiversity Framework, there's a protected area target of 30% already set. Now, I've argued that has never been made based on ecology or any evidence, but 30% is still quite a large number and seen as actually a big outcome for conservation. When you add that 30%, of protected areas that has been set by all nations, all 196 signatory nations of the CBD, and add it to the other target they've set, which is 30% of restoration, 30 plus 30, that's 60, right? So nations have already committed to what is needed to get through the bottleneck based on the broad analyses that we've done. We actually got retention targets, weirdly and by some fluke, which speak to each other and will get us through this problem that we're seeing right now. So we have the policy commitment right now, broadly, to go for what nature is needed to get through that capacity. We have the capacity to communicate this, and we have the ability to do the science. I'll remind people this data revolution is real. Our ability to map and protect these places has never been better, and it'll look increasingly important. So we can get through the bottleneck. There is hope. And once we know where these places are, we can then start saying where the protected areas are, where these other effective conservation areas should be, and where are these other places that nature needs to sustain people and connectivity, the ecosystem services, agricultural production. We can start mapping this out in a way that actually is which has a chance to get species through the bottleneck. Now, I know what you're thinking. I know exactly what you're thinking right now. You're thinking this guy is on the ivory tower. This guy is just producing these maps, publishing in places like Science, and this is garbage. This is not real world stuff. This is, 100 years from now, what are you talking about? I've got something to tell you. In Australia, something exciting is happening. And that is, our Minister for Environment has made it abundantly clear that her biggest priority is to set up regional planning frameworks which do exactly what I've just mentioned around getting that healthcare process going for biodiversity. Now, this is an incredibly long piece of text in a ministerial brief, but I just want to emphasise the fact that these are the ministers of the environment, and in both Queensland and federally, and they're setting up an MOU to get the Queensland government a methodology of mapping, modelling environmental values and development pressures. They're going to do 3 or 4 regional plans in the next year. So this is not an ivory tower thing. There is an opportunity right now to get involved and actually start planning for the bottleneck right now, given there's a Labor government in Queensland and federally that will actually want to push these plans. They've even set up a traffic light system, a simplistic traffic light system which says, where are the red zones? Where are the places where we can't develop, where we have to sustain nature to actually get through, they don't call it the bottleneck, but to give biodiversity a chance. They want to talk about orange zones as places where you actually do your EIAs and your planning and actually try and allow development to occur, but within the framework of the EPBC. And then there's green zones, which they've said this is a free-for-all. There shouldn't be any kind of analyses, that they should just be allowed development. But in those places, as far as I can tell, are degraded landscapes and seascapes that have lost their biodiversity and are unrestorable. So right now we've got a chance to actually get at the area-based conservation targets directly align into our traffic light system that the federal and state government is happening right here in Queensland. Now, I want to leave you on that note because this is hugely exciting, I think, for conservation. If we can start proactively engaging with these processes, and one of the processes is going to be up here in far north Queensland. It's called the Renewable Planning Precinct, I think they're going to call it. That to get in there and actually start mapping out and proactively showing that we need 50 to 60% of this place conserved for biodiversity and for ecosystem services, it's going to let species have a chance and ecosystems have a chance to get through the bottleneck. So I'm going to leave it with that by saying thank you so much for having me, and listening to my first depressing story at the start and hopefully a message of hope at the end. So thank you.